Hello everyone. So for your JEE Advanced 2026 preparation, I am giving you one questions which is based on determining the function, that is by using the Leibniz formula. That is, function is given to satisfy some equation which involves functions, integration, definite integration and all those things. Okay, then you have to determine the function. How to determine that? See, apply the Leibniz formula, then followed by the differential equation. So Leibniz formula, differential equation, all these concepts you have to apply over here to determine the function. So this type of variety of questions are very popular. And then once you find out the function, see here, let f r positive to r be a differential function satisfying this equation. What is the equation? Fx, I am writing once again, fx equal to e plus 1 minus x into ln of x by e, okay, and again plus integration of 1 to x ft dt. The function is satisfying this equation. So from here you have to determine the function first, correct? So therefore you have to apply the Laplace formula followed by the differential equation. So all those concepts you have to apply over here. Then you have to give these two questions answer. First one is just the integration of fx dx from limit 0 to 1. What is that? You have to find out. You can find out once you determine the function fx, correct? And then what is said, that the x-intercept of normal, okay, drawn to the curve, okay. So we have to find out the normal equation of this curve y is equal to fx. But normal equation at where? The point is what? At the point P, where y is equal to fx crosses the line x equal to 1. So the language of the advanced question is always difficult. You have to understand the language of the questions properly. It takes time, but no problem. In the advanced examination you have 7 to 8 minute time to solve a single question, correct? So crosses the line x equal to 1 means the point P is lying on x equal to 1 and also the curve. So putting x equal to 1, you can find out the value of y in the given functions. That will be the point P, correct? So at that point P we have to find out the equation of normal to the curve. That is simple, okay? So coordinate geometry, calculus, both the concept involved over here. So let's try to solve it. Now how we can solve it? See, first we will determine the function. What is given? Fx equal to e plus 1 minus x into ln of x by e plus integration of 1 to x ft and dt, correct? So ln x by e can be written as ln of x minus ln of e. Ln of e is 1. So this is, we can write it as a ln of x minus 1. Number 1 step. Now I will differentiate it. So this will give f dash x. The derivative of this is 0. And here I will use the product rule. So 1 minus x first, then derivative of ln x minus 1 is 1 upon x. Then plus ln x minus 1, and then derivative of 1 minus x is minus 1, and then derivative of this definite integration. That is your Leibniz formula, and that is only simply fx. Replace t by x and then take the derivative of x. Derivative of x is 1. Then minus, replace t by 1 and then take the derivative of 1. Whenever constant is there, constant is derivative is 0. Therefore simply write down this one. This is very simple, okay? You know that. So here I can write dy by dx. This 1 by x is multiplied here to 1 by x minus 1. This minus 1 is multiplied here to minus ln of x. Minus minus plus 1 plus y. fx is y. So 1 get cancelled out. So we are having dy by dx. This plus y is coming to minus y equal to 1 upon x minus ln x. minus ln x. So this is your differential equation. Now you have come to the differential equation like that, this form dy by dx plus py that is equal to q. So we have to find out the integrating factor. Here p is equal to -1, correct? So the integrating factor is e की power integration of p dx. p dx means -1, correct, dx, that is equal to e की power -x, correct? So this is your integrating factor. Therefore solution is given by y into e की power -x, e की power -x into q. Q is this whole, that is what, 1 upon x minus ln of x. Now you have to integrate this to find out the y, and of course plus c, the constant of integration, that also you have to determine. I hope that up to this step it is very clear how to find out the fx. Okay, first this equation, differentiate it, first simplify it. Whenever some kind of simplification needed in the questions, for example here it is given that the ln of x by e, therefore I can write down it is ln x minus 1 by applying simple logarithmic quotient rule, correct? Now we have come to the differential equation and solving differential equation to get the function fx. So dy by dx, so how to do that? Now it is also very tedious how to do that. So it is y into e की power minus x, this is e की power minus x into 1 upon x minus e की power minus x into ln x plus का c. So there are two integration I have separated, and definitely I will integrate this and keeping this integration as it is, because when we integrate 1 upon x I will get ln of x, got it? So definitely there might be the possibility of cancellation of this type of integrations by using by part. So I will apply the by part over here now. Okay, so this is what y e की power minus x, first function is e की power minus x into integration of 1 upon x dx. Integration of 1 upon x dx is ln x, correct? Then minus derivative of e की power minus x is e की power minus x into minus, this minus will come over here, it will become plus, correct? And integration of 1 upon x का dx, this 1 upon x का dx is ln x, this is ln x, correct? Now this integration and this integration with a minus, so I have just integrated this one by using the by part. So there is minus ln x into e की power minus x, this is cancelled out, and this is of course plus c, got it? Okay, so therefore now I have remained with y into e की power minus x equal to e की power minus x into ln x plus का c. So this is y is equal to ln x plus c into e की power minus x से divide करेंगे, so e की power x here. When we divide by e की power minus x, so c into e की power x, that plus minus also you have to take care. So finally we have to determine now c. Not c is still unknown there, so how to determine c, that is also important. Is there any condition given? If it is not given, then look at the differential equation. What is the differential equation? This one is differential equation given. Apna equation, that one is equation which is satisfied the function fx. That equation you see here, when I put x equal to 1, this whole term becomes 0. When I put x equal to 1, this also becomes 0. So when x equal to 1, this is 0, this is 0. I am remaining with e. So when x equal to 1, y is equal to e. You are getting that. Got it? So finally, now I can delete this one. Okay. So finally what I am getting, when x equal to 1, y is equal to e. So y is equal to e here. E equal to ln1. ln1 is 0, correct, plus c into e to power 1. So therefore c is equal to 1. So finally you are getting y is equal to ln x plus e to power x, that is your fx. Now y can be replaced by fx. So you have now come to the fx. This is your fx. And see the function ln x is also there, e to power x is also there. Both ln x and e to power x both are reciprocal of each other and both are there. So up to this, that function is satisfying some equation. From that we have come to determine the function as ln x plus e to power x, and that we have determined by using the Leibniz formula followed by differential equation, and also the constant c, how we can determine by using that given equation, that is also important. Now you can answer these two questions. So the first question is integration, simple integration. Integration 0 to 1 of fx dx, that is integration of ln x plus e to power x. So I can have two different integration, that is 0 to 1. E to power x का integration is e to power x 0 to 1. So e minus 1. So this is simply plus e minus 1. But ln x integration is x ln x minus x, and then we have to put the limit. So this integration is also very interesting. You have to remember always the answer of this is minus 1. How we can say? See, when we put 1, so this ln 1 becomes 0. So we are having minus 1. But I cannot put 0 directly over here because log is not defined. So I will take the limit. So minus limit extending to 0 positive. 0 positive I will take x ln x minus x. So this can be written as, and there here e minus 1 is already there, correct? Okay, fine. So this is minus 1. This is minus limit extending to 0 positive x ln x minus limit extending to 0. This is minus minus plus x. So this becomes 0. So there is no problem with that. But mind it, plus e minus 1. Now how to determine this x into ln x? This is 0 into infinity form. 0 into infinity form, that has to be converted into the infinity by infinity or 0 by 0 form, so that we can apply the L'Hospital rule. That is the way. So limit concept also comes there. So therefore it is minus 1 minus limit extending to 0. This is ln x divided by 1 by x, and this is e minus 1 already with this. Okay. Now I can apply the L'Hospital rule. L'Hospital rule is 1 upon x, and this is minus 1 upon x square. Finally we are getting minus x, and putting x equal to 0, answer is 0. So therefore I said that this limit x into ln x minus x when 0 to 1, the answer is minus 1, so that you can save the time. So this is minus 1. This is minus 1 plus e minus 1, e minus 1, that is equal to e minus 2. So e minus 2, here e minus 2. Here e plus 1. So therefore e minus 2 is your answer. I hope that you understand this. Coming to the second question. The second question, we have determined the fx. Fx is this one, huh? This is your fx. Okay. Now what is said? The second question. Second question is like that. The x-intercept of normal drawn to the curve y is equal to fx at p, where the y is equal to fx crosses the line x equal to 1. So this curve crosses the line x equal to 1. That point is your point P. So put y is x equal to 1. When x equal to 1, your y is ln1 plus e. ln1 is 0, that is e. So therefore P point is 1 comma e. This is your point P. So now you have determined the point P. Correct? You have determined point P. Now you can find out the equation of normal, very easy now. So what is f dash x? F dash x a is 1 upon x plus e की power x, correct? So f dash x at p means 1 comma e. So 1 plus e. So this is your slope of tangent. This is your slope of tangent, correct? So therefore slope of normal you can find out. Slope of normal is minus 1 upon 1 plus e. And therefore you can find out the equation of normal. Equation of normal is y minus y1, that is e. Slope is minus 1 upon 1 plus e. X minus x1, that is 1. Now the equation of normal we have find out, and we have to find out the x-intercept of this normal. For finding the x-intercept of this normal, we have to put y equal to 0, because they are asking about the x-intercept. So put y equal to 0, minus e, minus 1 upon 1 plus e, x minus 1. We have to determine x from here. So minus e square minus x plus 1. So therefore minus x equal to minus 1 minus e square. Therefore x equal to, I am writing over here, 1 plus e square. That is your x-intercept. So this is e square plus e minus 1. No. E square plus e plus 1 divided. No. This is also no. So this option is correct. E square plus e plus 1. So we have revised coordinate geometry, equation of tangent, equation of normal. We have revised how to find out the limits, 0 into infinity form, this concept, Leibniz formula, differential equation, so definite integration. All those concepts we have used over here. So such type of questions they ask in the JEE advanced examination.